Hey guys, here we are getting ready to do our fraction unit, and one of the things that we want to get down is a little bit of vocab before we get into that unit. And so we've got some terms here. Some of them may be kind of familiar to you. I'm actually going to kind of move down my paper and start with the term factor. Because as I explained prime and composite, I'm going to want to use that term. So go on down to your third vocab word there on your notes, and remember, if you don't have these notes, you can always print them from Canvas. So a factor is a number multiplied by another number to get a product. A number multiplied by another number to get a product. So we can say that 3 times 2 equals 6. These two numbers are our factors. And then that's our product. We can say that 5 times 2 is 10. Again, these two numbers are our product, our factors, and 10 then is our product. So some characteristics of factors is that we multiply the factors to get products. Now the opposite then, or the reverse of a factor, is a multiple. And what we do when we're looking for multiples is we take the number that we want to start with and we start listing its multiples. So the multiples of 6 would be 6 times 1, or 6, 6 times 2, or 12, 6 times 3, or 18, 6 times 4, or 24. So instead of breaking the number apart to find its factors, we're multiplying the number by whole numbers to get numbers that are bigger than the number we started with. So it's kind of the reverse end. We can break this number up to get its products. We can build this number up to get its multiples. So if I wanted to list the multiples of 10, I'd say 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, and so on. And of course the multiples can keep going on forever, whereas the factors, there's a limited number of factors that we can find for each product, but we can find an infinite number of multiples. So let's go ahead and fill in our multiple here. So a multiple is the product of any number and a whole number, right? So the product, a multiple is the product of any number and a whole number. So if we look at multiples, we can say for 7, we can start listing its multiples. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, and again, we can go on infinitely. Multiples are infinite. So again, we listed the multiples of 10 up there. Let's list the multiples of 4 here. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. Multiples, we multiply a number by a whole number to get multiples. Now again, the non-examples then are, for instance, the number 4. We know that 4 can be 4 times 1 or 2 times 2. Those are factors, not multiples. So if I break the number apart into the numbers that can be multiplied together to get it, those are my factors. Whereas if I'm building the number up, like this over here, those are my multiples. All right, So let's go on up then to prime numbers. Now prime numbers then are any whole number greater than 1 that has only 2 factors, 1 in itself. So this is any whole number. Again, we're focusing on whole numbers, which is kind of funny since we're getting ready for fractions, right? Any whole number greater than 1 that has exactly 2 factors. One and itself. So some examples of prime numbers are 2. The only factors of 2 are 2 and 1. 2 times 1 is 2. That's the only way we can break 2 down into its factors. 3 is another prime number. 7, 11, 23. Just a side note, 2 is the only even prime number because 2 is the only even prime number because every even number greater than 2, of course, can be divided by 2. Now remember, 1 is neither prime nor composite. It's kind of in a category all its own. 4, of course, can't be prime because it has the factors 1 and 2 and 4. 9 has the factors 1 and 3 and 9, so it can't be prime. 20 has more factors than 1 in itself. 16 and 39. All of these numbers can be divided by numbers other than 1 in itself. So characteristics of prime numbers, there are only 2 factors for every prime number. Okay? 1 is not a prime number. That's a good one to remember. All right, so composite numbers then are all the numbers that are not prime. Every whole number has to be either prime or composite. It fits into one of those 2 categories with the exception of the number 1. So composite numbers are numbers greater than 1 that have more than 2 factors, whole number factors. So these are numbers greater than 1 that have more than 2 factors. So 3 or more. And remember, we're talking whole numbers here. Okay, so examples then would be 4. 4 can be 1 times 4 or 2 times 2. So it has 3 factors. 9 has 3 factors, 1, 3, and 9. 50 has many factors, many more than just 1 and 50. 12 has quite a few factors. 27 has more than 2 factors. It can be divided by 3 and 9 as well as 1 and 27. All right, some non-examples. Remember, 1 is not a composite or a prime number. 3 is a prime number, so it can't be composite. 29 is a prime number. 11 and 7, all prime numbers, therefore, except for 1, so they cannot be composite numbers. Remember that composite numbers have more than 2 factors. All right, guys, watch the rest of the video here and answer the questions as you're asked on the Play Pause It. See you in class.